Alright, so 3.3, day 1. What we're going to take a look at today, everything that we know about quadratic functions. We'll look at how we've been graphing quadratic functions using our transformations, and we will also look at how we graphed quadratic functions in Algebra 2. Alright, so if you take a look at the screen, very first thing that I want you to do, read the characteristics that we know about quadratic functions to this point. Obviously, number 1, the parabola opens upward. Think ax squared plus bx plus c. This right here. We know that that is standard form of a quadratic function, so remember the ax squared plus bx plus c. If a is positive, meaning if your leading coefficient is positive, then your parabola should open up. If that leading coefficient is negative, then obviously your parabola opens down. So let's take a look at some of these. What I decided to do was put a parabola here for you. And what we just talked about, number 1, if that leading coefficient is positive, or if a is greater than 0, obviously that thing opens up. If it's negative, obviously that opens down. Okay, so there's one thing that we know already. 2, we know the vertex. Something new that is that I'm going to introduce. Vertex, we always usually label h comma k. So you can see there is the vertex. I label it hk, which is the point 2 comma negative 1. Okay, so we know our vertex is 2 comma negative 1, and in this case I know that that's also our global minimum. Remember, global means that it's the lowest point, or the highest point. In this case, it's the lowest point in which our parabola reaches. So it's a global minimum. Okay, so that kind of takes care of number 2. Third one, the vertex is below the x-axis, so there are 2 x-intercepts. Think we call our x-intercepts the point where it crosses the x-axis. I know the x-intercepts are the same thing as our zeros. Okay, so x-intercepts, zeros, same thing. I know they're labeled at points, so point 1 comma 0 and 3 comma 0. Okay, so that kind of takes care of number 3. Number 4, axis of symmetry. Think parabolas are always symmetrical. So the axis of symmetry always goes right through the vertex because it is a vertical line. Vertical lines are always x equals. So in this case, x equals positive 2. That is the x coordinate where our axis of symmetry goes through. Last one is our y-intercept. Y-intercept is the point where it crosses the y-axis. We also know that our y-intercept comes from, if we're looking at standard form, our y-intercept is always that constant at the end there. Okay, so our y-intercept is at 0 comma c, and now you understand why they use c, because think about your standard form. That's why it's c. Okay, so they're all the things that we should know about parabolas thus far. Hopefully that helped you out. If you didn't remember any of those, hopefully that kind of refreshed your memory. Obviously, looking at the title, you know that that's where we're going, and we're going to start looking at some applications. So it's important that you understand all of those things about your quadratic formula. Alright, so what I want you to do, let's see. Do you remember how to graph that function? Think about your transformations. How many transformations do you see in this problem? Hopefully you're saying that I saw 3 transformations in this problem. Can you tell me what are the 3 transformations? Okay, hopefully you're saying, okay, for 3 transformations, first one I know it's going to be a horizontal shift right one. And the horizontal shift comes from this -1 right here. Minus goes to the right, plus goes to the left. Second transformation would be the reflect x. That would be this negative out front here. There is your reflect x. Last, you have a vertical shift up 2. That would be this part right here. The +2 tells you have a vertical shift up 2. So hopefully you remember your parent functions. Hopefully they didn't travel too far out of your mind. If you plot your parent function and then apply your transformations, your parabola should look something like this. Okay, so last thing we're going to look at today. How do I graph this parabola? I know it's a parabola because obviously it's like squared. How did I graph these parabolas when I didn't see my transformations? How did I graph these in Algebra 2? So I'm going to kind of do a quick refresher from Algebra 2. If this is something that's brand new to you, please make sure that you're taking really, really good notes as we're going to graph this parabola using Algebra 2. Okay, so that's why I kind of put this is what we did in Algebra 2. Alright, so the first step was to find the vertex. In order to find the vertex in Algebra 2, we used that mini formula x equals the opposite of b over 2a. So think opposite of b is -8, 2 times a is 2 times 2. That gives me -8 divided by 4, which gives me -2. Okay, so from here, how do we figure out, how do we figure out what the y value is? Well, in order to figure out the y value, what we're going to do is we're going to take the x value and we're going to plug that into our function. Wherever I see an x, I'm going to plug in -2. Okay, so there you can see I plugged in -2 wherever I saw an x. And now I'm kind of just going to simplify this either in my calculator, I'm going to do it by hand. I'm going to choose to do it by hand. -2 squared is +4, 4 times 2 is 8, and then 8 times -2 is -16, and then +3. If I do that, it gives me -5. There is the y value. And if I think about it, there's the y value. I'm going to plot that point right there, -2, -5. I know that that is my vertex. Okay, so from here, what we did is, and this is where the tricky part comes in, what we did is we chose to do an XY chart. And that XY chart, what we decided to do was either pick 2 points to the right of my vertex. So think my vertex is right now at -2. So 2 to the right would be -1 or 0. Or I could do 2 to the left. Think, here's where my vertex is now, the x value. I could do -3, -4. Why can we choose 2 values to the left or to the right? Well, we know that parabolas are symmetrical, so if I find 2 to the left or 2 to the right, I can simply use my axis of symmetry, and because they're symmetrical, I know that it's going to be the same thing on the other side. I'm going to choose to do the easier of the two. I'm going to choose -1 and 0. So think about that. How do we find those y values? We're going to do the same thing that we did when we had the x value in our vertex. We're going to plug them in. When I plug them in, when I plug -1 in, I get -3. When I plug in 0, think I get +3, which I should have known that that's my y-intercept. So I'm going to plot those 2 points. I'm going to draw my axis of symmetry. I decided to draw that as a dotted line. I know they're going to be the same distance away on the other side. And voila, I'm going to draw my parabola. So think transformations, let's get those in our head. Graphing parabolas from Algebra 2, hopefully that's not going to be too difficult for you. You can see it's a long process. And hopefully you remembered all of that information from your quadratic functions. If not, let's make sure we study that. Listen to the video as many times as you need to, and we'll kind of go from there.